Good. Good. So let's look at image formation by a convex mirror. Can we draw that? Are you seeing that? Are you seeing this one here? This one here? Can we draw that? Image formation by a convex mirror. Image formation by a convex mirror. Image formation by a convex mirror. Members, are we drawing that? Can we draw that? Members?
Yes, teacher.
Are we drawing? Are we drawing?
Yes.
All right. Wait shortly. I'm going to connect my camera so that I share also my writing space. First, wait a minute. At first, be drawing this. Be drawing this. This one is very clear. The object must be facing the reflecting surface, because when the object is not facing the reflecting surface, there will not be reflection of light, because the reflection is from the object. The reflection is from the object. Yes? Members? Yes, members?
Yes.
Alpha,
Masa?
alpha. Yes, members? Yes, please. Hello?
Yes, teacher.
Are you able to see my screen now? Are you able to see my screen?
Yes.
All right. So let's go through that. Image formation, or nature of the image form by a concave mirror. I just wanted to show you how it is, how you should draw it. As usual, we start by drawing the principal what? We start by drawing the principal axis. After drawing the principal axis, you draw a vertical line, and this vertical line is representing the reflecting what? Surface. It's representing. So for convex mirror, we draw it like that. We draw it like this. And we said its principal focus is in the curved side. So which means you put it this side. You don't put it this side like concave. And I told you the distance between them must be equal. The distance between them must be equal. So I put this one here like this, then I put this one there like that. So this is my focal point, then this is my center of what? Curvature. So the object can be at any point here because this is the reflecting surface. So the object, we can put the object at any point here. Let's assume that the object is here. If the object is there, so that is our O. As usual, a ray of light parallel to the principal axis, like that. What will happen to it, members, when it reach here? We know that this is a convex mirror. What does a convex mirror do? A convex mirror is what? Diverge. A convex mirror is what? Diverge like rays. So which means it will, when it's diverging, it will appear as if it's diverging it from from the focal point. So this one is real, but this one is virtual, appears. This is virtual. So that's why you have to use a dotted line there like that. Then again, another ray of light will come from the object through the center of what? Through the center of curvature. So it will come like this. This side is now virtual. This side is virtual. This side is virtual, like that. Members, have you seen that? So now where the two rays are meeting, this now where will be the image. This is where the image will be. 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 So this is our image. What can you say about the image, members? What can you say about the image? This is reflected that. What can you say about the image, members? Who can? One, nature. What's the nature of the image?
It is diminished.
The image is what? Diminished. Good. One, the image is what? Diminished. What else? What else? What else?
The image is inverted.
Is it inverted? Remember, is it inverted? Yes, look at it well. Look at it well. Look at it well.
It is erect.
Is erect. Not so. The image is what? Erect or up? Upright. What else? What else can you say about that? The image is formed. This is the pole of the mirror. The image is formed what? Between the pole of the mirror and the what? And the focal? The focal point. Is formed between P and what? P and what? P and F. Members, is it real? Is it real or virtual? Is it real or virtual?
It's real.
No.
Virtual.
Why are we saying? Because it's formed behind the reflecting surface. Okay? So which means the image is what? The image is it? The image is virtual. Are we together?
Yes.
Yes. So that's how we draw it. Now, there's one thing good with the convex mirrors. For convex mirrors, no matter where the object is, even if the object is very near here, okay, the image will still be formed between P and what? F. Even if the object is very far away from the mirror, the image will still be formed between what? P and what? P and F. Are you together, members? It's not like for concave mirrors where we have to keep, because for it, the principal focus and the center of curvature, they are what? Virtual. They are behind the reflecting surface. So no matter where the object is, the image, this will be the nature of the image form. The image will still be diminished. The image will still be upright. The image will still be formed between P and F. The image will still be what? Virtual. That's why I was saying, write down note. For convex mirrors, comma, irrespective of the object position, the image form is always between the pole, between pole of the mirror, and the focal point, and the focal point, or the principal focus, Diminished. The image is still diminished. Upright, and virtual. Upright and what? Virtual. Upright and virtual. Are we together? Members, are we together?
Yes.
All right.
Yes.
All right. So we have already seen, the uses of convex mirrors. That one we are not going to repeat it again. We have seen parabolic mirrors. That one we have already also seen it. But there's something very interesting I want us to look at today. We have seen how we can draw this ray diagram. That one we have drawn it theoretically. Members, we have drawn it what? Theoretically. Now we want to see how do we draw it also graphically. How do we draw it graphically? Subheading, members. Let me take you there. Subheading. Graphical subheading. Graphical method. Of determining. Image position. And nature. Graphical method of determining. Image position and nature. Full stop. So you can see the steps in my screen here. You can see the steps. So step number one, on graph paper, draw a central horizontal axis, which acts as a principal axis. Like we have been drawing, we draw this one. Now you must use a graph paper. Let me hope everyone, you have a graph paper there at home. If you don't have it, then we need it. We have some 9 minutes remaining, but let's first explain the steps so that when we come back in the second session, we shall start drawing them. So the first step is, maybe before we look, let's write this statement down. Let's write this statement down. You said we can use graph papers. To determine accurately the nature, magnifications, positions of the image form for curved mirrors. That is concave and convex. Mirrors. So what are the steps? Now let's look at the steps. Steps number one. Step number one, what is the first step there, members? On a graph paper, draw a horizontal Draw a central horizontal line which acts as the principal axis and with a perpendicular line, like we have been drawing here. You drew the same on a graph paper. You do the same. This line here, you draw a horizontal line with this line is acting as a principal axis. Then this line is acting as the reflecting surface of that particular mirror. If it's a convex, this is how you draw it. If it's a concave, we know how to do it. Now, where these two lines are meeting, they are meeting perpendicularly. So this point here is going to give us now the the pole of the mirror. This is going to be the pole of the mirror. That is step number one. Step number two, where distances are given, choose a given scale for object size and the position. Choose a given scale. Now, which means here you must also remember something to do with scale. Step number two. Now, that one is very important because sometimes they give us this distance which we cannot fit in a graph paper. Like 10 centimeters, 20 centimeters. So these distances cannot fix in our graph papers. So what do? We must scale them up. We use a scale. A scale. So which means you must also be familiar with scale. Which that one I think is not a problem anymore. So you must also be in position 2. It must be a suitable members. Our word is what? A suitable what? A suitable scale. And we said a suitable scale is a scale which is easy to use. Easy to use. Any scale which is easy to use and convenient to use is called a suitable scale. So you use it, determine the scale using the information that I've given you. In case they've given us the object position, this one, if we have the object position, we sometimes we refer to as distance. I believe you remember that. Then if they've given you also the image size, now the image size, the object size, I'm talking about the height. Here you talk about the height of the object. Those are the things we need. Then step number 3, measure the focal length. In this one, if they have given us the focal length, who can remind us what is focal length, members? What is focal length? Who can remind us what's the focal length of a mirror? What is the focal length?
This is the distance. Is the distance from the pole to the principal focus.
Focal length is the distance between the pole of the mirror and the principal focus. The distance from here up to this point is what we call the focal. Focal length. What about the distance from the pole of the mirror to the center of curvature? That distance is called what? What about from here up to that point? That distance is called what, members? What about from here up to here? That distance is called what?
Radius of curvature.
Is called radius of curvature. Perfect. And we said, what do you remember about what's the relation between focal length and radius of curvature? Who can remind us? What's the relationship between them? What's the relationship between them? The relationship between F and R. Who can remind us? What's the relation between them? We said radius of curvature is how many times? Is twice the focal length, which implies that F is equals to R over what? R over 2. This information is very important here because sometimes they may give you radius of curvature, which means if they have given you radius of curvature, you can use it to determine the focal length. If they have given you the focal length, you can use it to determine radius of curvature. Are you together? Members, are we together?
Yes.
Yes, take note of that. That is step number 3. So you measure the focal length and radius of curvature. And we say the distance between radius of curvature, they are equal. That's why we're saying is twice, because which means the distance between them must be equal. So the distance from here up to here must be equal to the distance from here up to that point. So if from here up to here is 10, even from this point up to here must also be 10. They must be equal. So you measure that as well. Then step number 4. Draw 2 principal axes. Actually, it should be parallel axes. You draw parallel what? Rays. Who can remind us what are parallel rays, members? What are parallel rays? What are parallel rays? We said parallel rays, these are what? Parallel rays. Parallel rays are what? Are rays which are what? Which are parallel and what? And close?
Close to the principal axis.
And close to the principal? To the principal what?
Axis.
Principal axis. So we consider only rays which are parallel and close to the principal axis. And we said for the image to be formed, how many rays do we need to draw, members? How many rays do we need to draw? When you look at how we are drawing them here, how many rays do we need? How many rays do we need? We need 2, not so? We need what?
2.
2 parallel what? Rays. And this one lead to the formation of what? This one now will lead to the formation of what? To the formation of the image. So where the two reflected rays meet, that will be the formation of now where the image will be formed. Then the last step, after drawing that, then automatically it must give you now what? It must lead to the what? It must give you the image. Sorry, it must give you the image what? Members, the image what? Position. And when we talk of image position here, we are talking of the image distance. We talk of the image distance. And all the distance here must be measured from the pole, all measurement must be from the pole of the what? Members, if you remember, must be from where? From the pole of the mirror. Is that okay, members? Is that okay?
Yes.
Yes. So all measurements must start from the pole of the mirror. Then from also this one, you can also determine the image size. You can also determine the image